just wanted to take a moment to go over some more of the questions that have come up about the project for the next part. I want to do a quick review over some important things from part B, then we'll move on to the new content from part C. All right, so originally you made your introductory slides for yourself and for your topic. Relatively short project so far for part B. We're going to expand on that. Part C is a little bit longer. D is also going to be a little bit longer, and then E is going to be shorter again later. So please remember that when we make part C, we want to add it to the end of part B so that we're growing the project and eventually we'll have the whole thing together. Remember again that for each different partner, you need to have a different version of the slide for each different minor objective. Okay, so the major objectives are going to be like 1, 2, 3, 4. That's the part in front. Then the minor objective. Objective 1 is split into minor objectives 1.1 and 1.2 and 1.3 and 1.4. For my examples, I just skip straight to 1.4. So, just as a random part of the example. So remember again, there's a partner and a slide labeled for the partner. So that name is here. The minor objective and the part are labeled. And then again, what's being covered is clearly labeled. All of these things need to be here. I'm looking at many hundreds of students and thousands of slides by the end of the semester. Sometimes I can't tell what somebody's trying to present. Occasionally they're mixing up topics. They've changed the order or they're combining things. Sometimes I have no idea how some of this information is meant to relate back to the content. So please label what you intend for this to be. That way it's easier to make a decision to see if it fits. Otherwise, if I can't tell, it just won't get points. All right, so moving on. Different partner, similar labels. So again, this is for 1.4, which is part B. It's about relative scientists. Again, that's clearly indicated, but notice that this is in fact a different scientist, right? So first one's Galileo. Next one is Newton. So each person needs to have a different version of each slide. Now, where a lot of people got kind of stuck and started asking questions, if this was the scientist that you picked for part B, is this the scientist you need to focus on for the entire project? Now, in an ideal world with infinite time and resources and planning and understanding, then you would be able to do the whole project all at once. You would, find a scientist and it would be a perfectly matching idea and everything would relate and it would all be perfect. That's not typically the world we live in. So it's not important that you commit to the same scientist the whole way through the entire project. What needs to stay steady is the overall topic. So if you have to deviate from this slightly to have enough content to cover, that's okay. But as often as you can and as quickly as you can, come back to the topic. This is your focus. So if you had to pick kind of a weird scientist in 1.4 in order to have something different than your partners to say, that's fine. Get back to whatever your topic is for part C and for the other objectives. Okay, so like I said, we do want to continue on the end of our project. So this is my my guide file that I shared to everybody. The 1.1, 1.2, 1.3, 1.4, all here. Again, there would be multiple versions for each student, but to keep this to a smaller file and easier to show around, that's not fully fleshed out here. Then you've got your recording for part B, and then you would start part C. Okay, so again, add this to the end of your previous part, and then we keep going. This is longer. So part C has a major objective 2 and 3. So notice objective 2, point 1, point 2, point 3, point 4, and then objective 3, point 1, point 2, point 3, point 4, and then a recording for all of that at the end. Excuse me. So your recording only needs to be over the new content for part C. You do not need to re-record everything. Just record your new slides and then add a video that just goes to those same slides. Okay, now for these topics and these objectives. Again, we're looking at major objective 2 and 3, which means minor objective 2.1, 2.2, 2.3, 2.4, and continuing 3.1, 3.2, 3.3, 3.4. Let's double the stuff this time, potentially more than that, because your 1.1 slide just was your picture and it was basically free. So now we've got content for all of this. broken into two main objectives. We've got original everything, so original process, original difficulties, original motivation, original benefits. So basically, you want to think back then, when the scientists were first discovering or about to discover or just recently had discovered, all around that time period. So anything that says original should probably be at least 100 years old. In some cases, it may be hundreds or even 1,000 years old, depending on what your topic is. You really want to think way back when, back then, old times. We want a before and an after, a then and a now sort of comparison between these two objectives. If you notice that when you get into major objective 3, all of these things say modern. So modern means now, current, as recent as you can find. So hopefully with modern, everything you're talking about is at least since the year 2000. If not, get as close as you can get. But all or most of these topics should have really some updated science within the last 5 or 10 years. It might be that it's more precision, further decimal places on a constant, or it could be that we've redefined something, or now we've got lasers or cryogenics to help. But again, we want to look at anything modern. What is new that didn't exist before? How are things better or more precise than they used to be? Again, that's the other side of the focus. And then, future expectations going even further. So, what are some things that we hope we can do soon? A lot of times these topics are about space and robots and quantum computing and, all kinds of stuff. So again, feel free to get creative with these, making sure that it still relates back to your overall topic for your project. Okay, so now to get a little more specific and answer some of the questions that have been coming up. For the original lab environment, sometimes that's not even a real place. For some of these ideas, these concepts, they were first somebody's thought experiment, sometimes called a Gedanken experiment. It's a German word. Sometimes there were no physical setups or things to build or measure. It was somebody that was just thinking through a concept and coming up with the formula. Einstein did that a few times. There's a lot of stuff that he did that we still can't build and test because it was incredibly complicated. So the original lab equipment, similarly, and I guess the original experimental procedures, that might be some person sitting around thinking in a room, right? But that's how some of these things started. And then again, you want different students to talk about different parts of this, so you may have to go a little bit further along or think a little bit laterally to come up with some different information to cover. So, maybe they were different versions of the thought experiment, or maybe they're shortly after, in the next couple of decades, somebody was able to build something to start testing. Just basically, how did they get started trying to do the work for whatever the discovery ended up being? Again, one student per slide, one slide per student. So each of you in your group, if you've got 3 people, there will be 3 versions of the 2.1 Partsley slide with different things on them. The original difficulties, that could be a lot of stuff. Some of this even goes back to, like I said, there were thought experiments for some of these things because there was no way to even build and test the setup. They had no idea what to do. Safety issues, oh boy. There were a lot of things that they started studying that were incredibly dangerous. Radioactive materials come to mind. A lot of times they didn't know that what they were dealing with was very dangerous, and eventually people got horribly sick. Equipment issues. Sometimes they'd have very high or very low pressures, very high or very low temperatures that were very difficult to control. And again, you want to think about something that you can say has changed since then. So, here's your connection between objective 2 and objective 3. So there may have been safety issues with, say, open flames originally. And then these days, in current decades, what are we doing instead? Right? So again, one student per slide, one slide per student. Everybody needs to have a different version of 2.2. Okay, then what was the motivation back then? Why did they even go through all of this trouble? A lot of these experiments were very complicated and sometimes very dangerous. Some of the early experiments with electricity come to mind with some very hazardous conditions. Okay, again, radioactive materials also come to mind, very hazardous conditions. So why did they go through all of this trouble? What were they trying to figure out? What was going to be the benefit? So it's also important to indicate sometimes these things were discovered entirely by accident. You know, what were they actually trying to do when they ended up discovering something else? So it might be that the benefit or the goal was not at all what ended up happening. So if the experiment was an accident, this would be a good time to talk about that. Once more, one student per slide, one slide per student. Everybody needs to have a different version of 2.3. Okay, original benefits. So once this was done, you know, regardless of the expectations, who did it actually help? Again, sometimes these things were meant to go one way, went a different way. Things were discovered accidentally. Materials behaved differently than expected. But you know, what were the immediate advancements, right? So if some kind of new science was born, if new machines were able to be made, if new detectors came about, basically right at that time, what were the things that got better? Okay, so think about those things. One student per slide, one slide per student. Remember, everybody needs a different version of 2.4. So there should be one for each and every different student. Okay, then we keep going. Like I said, part C is longer. So this is still part C. This is still part of the same project portion. Modern lab environment. So typically the work that's done now in the field is completely different than it used to be. Now we've got lasers and detectors and I mean gravitational wave detectors are something that are very, very recent in terms of science. These didn't exist before. This is something that was talked about a really long time ago, but it's only pretty recent that we've gotten actual measurements from these. So the new procedures are probably completely different than they used to be. Again, you might think of some of the safety issues that existed before, and they're probably not there anymore, or they're not as big of a concern anymore. One student per slide, one slide per student. I say this over and over again because people are still not doing this, but make sure everybody has their own different, unique version for each one of these minor objectives. Okay, so like I said, we're thinking about how things are different now, how we've made advancements, how everything's safer. There are some parts of 3.1 and 3.2 that can kind of bleed into each other. So, you know, I mentioned safety in the last slide. That's something that would be here. You could put it in both places, but just, you know, make sure that each of you talk about something different. If you're focusing on a slightly different version of the experiments now or slightly different time periods, again, make that obvious. Make sure everybody has unique slides different from each other. Everybody's got different pictures. Communicate enough to make sure that you're not overlapping any more than absolutely necessary. Okay, so another big thing, information processing might actually be a lot better now. Previously, sometimes they were looking at developed films and taking manual measurements and graphing things by hand and calculating numbers by pencil and paper. And these days, we have a lot more complicated software. We have better cameras. We have digital methods for doing all of this. So that could be something that you mentioned here. Almost forgot. One student per slide, one slide per student. So make sure each of you has a different version of 3.2. All right, 3.3. So the benefits now. This may be completely different than what it was before. So, you know, the people who use technology now are not necessarily the same kinds of people who had access before. There are a lot of things that used to be only for governments or large universities that are now commonplace. For several of your topics, you might talk about cell phones. Everybody has a cell phone or a computer now, and that might be something that came about from your topic. There may be new fields of research that, you know, quantum cryptography and all kinds of stuff that exists now that was science fiction not too long ago. Brand new technology and machines and equipment. Again, all of these things that came about based off of your topic. Make sure you are talking to each other enough that they're not overlapping, right? So find different technology to talk about. If all of you talk about cell phones, then that's not going to be good. 1 student per slide, 1 slide per student. Everybody needs to have their own version of 3.3. Okay, last major slide for this bit. So for the future, this is all, predictions, and they don't have to be correct. I'm not going to come back in 20 years and contact you. Oh no, your project wasn't right. If you look back at some of the science fiction from the 50s, 60s, 70s, they thought we were going to have flying cars already. There are very few flying cars if you look up in the sky. So, these are guesses. These are things that we want. So potential benefits. What are some things that scientists hope they can do? What are some things that people hope will be invented? So, these might be entirely guesses. Maybe they're right around the corner. Could be something that is very close to being developed and released, or it could be just pure fantasy. But make sure you've got a picture, make sure you can relate it to your topic, make sure you've got a source, and most importantly, 1 student per slide, 1 slide per student. Make sure everybody has a different version of 3.4. Okay, then when you've made all of your slides, you need to record over your own slides. You only need to record over the new slides, so you don't need to re-record over part B. If your recording was messed up or missing parts or portions for part B, that's a different thing. That's a different submission. So you can fix that. You can request an extension for part B and you can resubmit in the old assignment. But that's going to be different than what you're working on now. Part C is a different submission assignment and should be what you're working on now. Now, this is the same random example video. So if you look carefully or go back and check, this is the same code that was on the end of my other link, because I literally just copied my slide and changed it to be part C. You should have a different recording now because you should have recorded over your new slides. Now, this is the first part where we sometimes run into trouble. If you have an unverified Google account, so if you just made it or if you weren't the person who uploaded last time, sometimes there is a time limit. I don't know, some students have told me 15 minutes or 30 minutes where they can't upload a video past a certain length, or maybe it's a certain file size. I'm not sure what the restrictions are. If you have to, you may need to have separate links for different people. Or if you put your video all together, at multiple links that are all for your part C recordings. That's fine. It's not ideal. It'd be better or easier on my side, at least for grading, to have 1 link to copy over. Remember, some of you did this before. You must give me a link that looks like a link. If you replace the words with something else, I am not going to be able to open that. You need to use a YouTube link. So a couple of people also ran into an issue that they embedded the video into the PowerPoint itself. You can't do that either, because once you save that as a PDF, your video turns into a picture, and I can't do anything with that. So make sure you've got an actual link that looks like a link. I'm looking for that code. It can be in the shortened format or the longer format, but do not replace your text. Do not use any alternate wording there. It needs to be the big ugly link, whatever you get from YouTube. On the other side of that, a few of you apparently emailed links back and forth to each other while you were communicating. And sometimes you got the safe links link, which is really long. It's like 10 lines or more on some of these. That happens when it gets scanned by Outlook or some other mail services, depending on what you're using. Try not to post that link. If you're not sure how to fix it, send it to me with enough time that I can look at it and send it back. Usually what happens is you get a bunch of codes around this, percent something, something, different signs that represent these symbols. If you look carefully, you'll still be able to find a V equals or a long, ugly code like that. But, communicate with me if you have any issues. If you have questions, please ask. Again, in a couple of weeks, I'll give you a recording for part D. That's just carrying on similar things. Now, I will go ahead and give you the hint. You're going to need to make a new practice problem. So something similar to like the lecture problems if you check the YouTube videos that are shared. So you might want to go ahead and start thinking about that, because you each need a different question. It needs to be something that requires numerical solving. All right, so it needs to have numbers, not just concepts or pictures, A, B, C, D, multiple choice. I don't want to get too far into that. That's going to be a separate video. Like I said, if you've got questions, please let me know. Otherwise, good luck and thank you.